Hi, this is Grover with Blue Collar Codes, Quick and Dirty, episode 25. We're going to go over data structures and just the tree data structure. This is episode 25. Again, you can find this file and follow along, GitHub repository linked in the video summary. So what we're going to cover is just what is the tree structure, how can you implement one in simple terms, and then we'll walk through an actual implementation of the tree structure in Python, and then why you want to use them, and then some different types and their benefits. So what is a tree structure? Essentially, it is a way of organizing data that has one root node or value that's a reference is maintained for, and then from there you are pairing up, or it can have as many children as you want, and then those children can have as many children as you want, and so on and so forth. And that's for a general tree structure, and the way to think about that or visualize it would be just thinking of a file system. You have the C upper level, highest level directory, and then within there you have as many folders as you want. That within those folders you have as many folders as you want, and you can traverse as deep as you want. But if you go all the way up that tree structure, that directory structure, it ends with C. And so that's a simple way of thinking of how trees, the tree data type is structured. Now, how to implement one is, in my mind, I would utilize nodes, class nodes, instead of trying to utilize an array structure, which is you can implement them either way. But you would basically create a base node, and you would make that an origin point. You'd create one node originally that becomes your root, and then you would create a bunch of other nodes, and then now you would start adding the nodes you want to be the children of the root node to that root node's list of children nodes, and then so on and so forth. That's how you would organize and implement it in simple terms. Now, the actual implementation can differ. Like I said, you can use the node class, and you can create your own elements within here, or you can use an array structure, but it depends on what you're going for, what kind of data you plan on storing. And so in my mind, it's easier to visualize when using class nodes, especially because your graphical representations online often use little circles and lines like a family tree, and that resonates with tree nodes or nodes for me. And so you can create this base class node class differently. You don't necessarily need to have a reference to the parent. You can maintain a reference to the parent using, making a specific algorithm if you want to be able to traverse the tree backwards, but you do not need to. But it depends on what your use case is. But if you want it to be easier for each child node, you can make a reference to the parent. So if you want to travel up the tree, it might be easier with that reference, but it would have more memory cost to it potentially. And so the actual implementation would be to have a constructor that gives the initial value. What it's going to do is assign the highest level reference, like your C directory, but it's going to create a root node with that value, and that becomes your main access point for this tree traversal when you're searching for values. And then you have a method that you would want to add children, and you need to pass in the parent's value, and then you would have to pass in the child's value. And so for this, you would have to search the tree structure using this method, which it defines down here. Once it finds that parent value, it will return actually the reference to the node itself. And then it's basically stating here, if there is an actual reference, it's not returning none, then create a new child reference, create another node, and then use this method up here to add that new node as a child of the parent node. And now we're not going to dive too deeply into how the find node method works, simply because that deserves its own video, and I'm trying to keep these relatively short, 5 to 10 minutes. And it is recursive, so that would require a bit more, in-depth looking at how it is actually functioning and how it is, making a stack of calls to find that node. And then here, self-explanatory, it's actually using that same search algorithm right there to print all the values too. So we're not going to touch upon that right now, but I will in another video. The other unique thing, like why using trees, is just for certain types of data, it can make searching for certain elements of that data much faster and easier. One of the best ways to explain it would be with the binary search tree. And all these different types of trees are basically just giving you more rules as to how you need to organize your tree, and it creates more limitations as to how many nodes you can have per parent. And so the one I'll go over touch upon now is the binary search tree. And the rules as to how that tree needs to function is that each parent node can only have 2 child nodes, and the left child is going to be less than the parent, and the right child is going to be greater than the parent. So if you think of implementing that, you would have, let's say, a root node that was 50, and then its right child would be the tree that would be created from the right child, or branched from the right child, would be all values greater than 50, and then the left child would be all values lower than 50. So if you imagine looking for a number within a tree structure, a binary search tree, it would be a lot faster than, say, looking for a number within an unsorted array. And so hopefully that was beneficial. Again, this is Grover, Blue Collar Codes, giving you a rough overview of the tree data structure. Thanks for joining.